Hi, this is Dan Bullard sitting on the river. This time I'm out in Little Ambition and we're at Fort William Bend. And if you look at Multnomah Channel, you can find Fort William Bend. It's pretty easy. I'm out here, I'm always talking about fun things, and I want to talk about some of the fun things I did when I worked in electronics. And I highlight a lot of them in the Reluctant Road Warrior. And also, my professional stuff, and you look around my website, you'll see all the stuff I did. Where to start? I started in the U.S. Navy, went to school, kicked ass, went to San Nicolas Island, went to Australia, which I really loved, and then went to Mare Island in California, Vallejo. And we lived in Vallejo, and then we moved down to San Jose, and I got into the Silicon Valley thing. And in Silicon Valley, I worked at a little tech school called Technical Training Center, and it was great. It was a great education and a great, well, it wasn't a great job, but it was a great education, good way to get started in Silicon Valley. I learned all about microprocessors. We used the 6800 microprocessor, and I used to write in machine code. I used to write 86, whatever, blah, blah, blah. 86 is the opcode in hexadecimal for getting up to loading the accumulator A. And 96, I think, was accumulator B, intermediate mode, and, we did all that stuff. And I did shift, I wrote code on the fly, had a good time doing that. Then I got a job with Genrad, and that was purely by accident. Some of my students went to Genrad for a job fair, and the manager said, we're not looking for any, just schooled people, but we are looking for people who are teachers. And they said, well, our teacher's great. And so they hooked me up to Genrad. Genrad called me up and said, hey, we want to talk to you about this teaching position. And boom, next thing you know, I had a job at Genrad. So I was working at Genrad. And they were doing a really crazy thing there. Their maintenance training course on the Genrad GR16 was going page by page through the schematics. It was miserable. And the guy that I was working with had all the schematics on transparency, and he had a little felt pen that he would make notes on, and all of his transparencies got stolen. And so basically he was starting from scratch, and so we had to go through page by page. That's just a terrible way to go. So I decided to do something very different, which was I drew up diagrams of the boards, basically drawings of the boards with the important registers on there, and I went through the boards that way. And it was a lot more humane. It wasn't, register by register. I still made them learn the registers manual, so we went register by register through the registers manual, but they didn't have to look at all the schematics, and they could if they wanted to. They were given the schematics, but they didn't have to use them. And we did all that, and I got to do a lot of interesting things there. I was assigned to teach the new class on the test pattern processor, TPP 204. I took on the algorithmic pattern generator, which up till that point, no one would touch, okay? Jim Healy had written about it in his book, Automated Testing, and it was, I don't know if it was clear to me. It just took a long time for me writing it and figuring it out to figure out what was going on. But no one would touch it. And one of the guys that I worked with said that he couldn't do it because he wasn't a test engineer. And I'm like, well, that's not reasonable. So I figured it out, and I wrote the class. I created the course for the APG, and I think I only taught it like twice, but it was a great course, and we did some fun things there. We tested DRAM, 16K DRAM, I think, and we tested a ROM, and with the ROM we did a ROM learn. So we put the ROM in, you executed the learn algorithm, it captured the contents of the ROM, and then from there on out you could test ROMs, and it would validate that each ROM was identical to the one that you learned. It was a really cool thing. The learn mode was kind of a nice feature on the Genrad. And I never actually saw that mode on any tester other than that. That was it. Now, most of those other testers, yeah, you could write a ROM learn mode, but they didn't have them. So that was kind of odd. Once Genrad started going down the tubes because of the LTX Trillium, I ended up moving over to Nextest. And at Nextest, I thought I was going to be teaching digital, but they said, hey, you want to try this mixed signal thing? And I'm like, yeah, okay, sure. And I did it, and it was eye-opening. I had worked with a guy at Genrad who had worked on LTX mixed signal testers, and he had talked about how cool they were, and I had no idea. Well, now I knew, and I was just in love. I just loved mixed signal. APGs, digitizers, doing algorithmic pattern generation at the same time. It gets wild. So I had a good time with mixed signal, and I did all the course development. I did a multimedia course for mixed signal. I did all kinds of stuff, and I was the expert at mixed signal. In Credence, they didn't really want to do mixed signal, but I kind of led them kicking and screaming, and we pulled it off. We sold a lot of mixed signal testers. And then Credence bought a division of Tektronix where they were making testers, the semiconductor test division, or semiconductor test, whatever. And that division was doing digital testers and just beginning to do mixed signal. And so I got into doing mixed signal there, and so I did, I despise the digital on that tester, but, it was worse than Genrad, but still it was faster, so it was okay. But I did all those crazy things that you do. I wrote an AM transmitter so that I was transmitting AM from the tester in the lab, and I could pick it up in my car radio, on my car radio in the parking lot. I did the NTSC color bars, never twice the same color, and that was using the Packet AWG. I did all kinds of crazy things. I worked out a way to measure capacitance on the pin cards using the active loads. That was cool. And it came out to like 30. Somebody asked me how much capacitance do the pins have? And I didn't know, but I worked out a way to figure it out. And I did that by setting the IOH and IOL so that it generated a linear ramp. And when you have a linear ramp coming out, feeding to a capacitance, then you can measure, if you can measure time, you can measure the capacitance. And so I can measure time. I can set VOL and VOH, and I could measure the time it took to go from a low to a high, and from there you have capacitance. So I could easily measure capacitance. And I wrote all kinds of test programs for all kinds of crazy stuff. And I did load board design, and I did some instrument design too. I did some pretty cool things. And just did some amazing stuff. In The Reluctant Road Warrior, I talk about a case where when I went to work for Next Test, I did a lot of things. I did a thing called, when I was at Credence, I did a thing called speech, where I digitized the speech from a microphone. And it was pretty cool because it didn't actually start recording until you started talking. Now that's sort of true. What it did is it started recording all the time as soon as you started the program, but it wouldn't count down and stop recording until you started speaking. So when you started speaking, that would trip a match mode in the tester, in the digital. And okay, you dropped from one loop into another. Now you're going to go through that loop until you filled up the memory in the digitizing voltmeter. And that would count down 4096 samples, and then it would stop. And so whatever you had, I think it came out to like a half a second. So whatever you said in that second or half a second, it captured that. And you could do amazing stuff, and it was all automatic. So it was really cool. Then I went to Schlumberger, and I went back to Credence, and then I went to Next Test. And the Next Test, I was doing more interesting things. My boss there, Rick Carmichael, was kind of a crazy man. He always came up with really crazy things. And one crazy thing he wanted me to do was how to measure the Doppler shift using the tester. Now, Doppler shift, everybody knows, right? That what was Sheldon for Halloween? He was the Doppler shift. And so what we did is I tried a lot of different things, but Rick was into models, and so Rick decided he wanted a G-scale train. So we got the biggest scale train you can get, G-scale, and got 20 feet of track. We bought all this stuff, and we built this thing up, and so the train would sit at the station. It would sit at one end of the track, and it was covering an optosensor. And over by the track was a crank that you cranked on. It was connected to a generator. And that generator output went to the tester, and the tester could measure the voltage and produce a proportional voltage to go to the train track, but with the current capacity to get the train going, which G-scale takes a little bit of current. So it would sit there, and you could crank on this thing, and it would generate a voltage, and then the train would up and take off, uncovering the optical sensor, which told the tester, okay, because it's a digital pin, tells the tester, okay, the train has left, it's now moving. And when you do that, it starts digitizing. There's a little station house, there's a little train station house with a microphone in it, about 2/3 of the way down the track. And so you're cranking this thing. On the train was a SonAlert. Okay? Now SonAlert is cool because whatever voltage you give it, it always gives you the same tone. It never changes the tone. So that's a really cool thing. So SonAlert, you know, the beep, 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 when you're getting backed over by a pickup truck, that beep, beep, beep comes from the SonAlert. And it's always the same tone no matter how much voltage is applied. Well, that was on the train. And so as we applied more or less voltage to the train would go slower or faster, and the speed of the train controlled the pitch from the SonAlert, not the voltage. And so the train would streak past the station, and remember the microphone was in the station. When it went past the station, you would get that, and that sound change is your Doppler shift, and you can tell the speed of that train based on the Doppler shift. Now, as the train moved on down, we don't want to forget about it because we only have 20 feet of track. And so when it got closer to the end of the track, it would cover up an optical sensor, and that would tell the tester, okay, stop with this nonsense, put the train into reverse with a very low voltage. So that basically put the brakes on the train. It came to a stop, and then it started slowly going backwards, back to cover up the other optical sensor at the other end of the track, and then the demo is done. So the whole thing is done. So now, when you trip that optical sensor to say, hey, we're getting close to the end of the track, that's when you stop digitizing. And you take everything that was gone back to wherever you started, that you digitized, you go backwards and you take all that and you do the FFT on it, and then you can look at the spread of the frequencies and you can see how fast the train was going. And it was a simple formula. I documented my stuff, simple formula, and we had a ball with that. Now, Rick had told me he was going to do a thing. He was going to make a tunnel, and so this was going to be the light at the end of the tunnel. Next test is your light at the end of the tunnel. And for the light, I was going to be the light. And so he wanted me in a white tux. Okay, so I went to the place where you rent tuxes, and I got a white tux with white shoes, the whole shebang. And so I showed up for the sales meeting before we talked about, doing the actual thing. This was in Charlotte, North Carolina. Rick told everybody Dan's going to do this thing, and he's got a white jacket. I said, no, Rick, you told me a white tux. I have a white tux. Now, I don't know if you know what it looks like. White tux is very impressive. And so every day, it was only 3 days, every day of the show, I was at the Charlotte Convention Center, and we had a big Hilton just down the street. So I'd walk over to the Charlotte Convention Center, go inside wearing my white tux, and people were astoundingly nice. They opened the door for me. They moved aside. They treated me like royalty. It was fantastic. And I would do this demo, and I had this one guy, I was doing this demo, and the salesman was actually kind of explaining it, and I tried filling it in because I was more technical than the salesman. I knew the details more, but the customer told me to shut up because he thought I was just a talent, right? He didn't know that I was actually the guy who did all the engineering behind it. But it was fun. It was really fun. Everybody treated me great. Even the CEO. One day, we're going home, all done with the day. Go to get my black laptop bag, and he grabs it out of my hands. And I said, Robin, I can carry my laptop bag. He says, no, you're the talent. You carry nothing. And he carried his laptop bag in my lap. This is the CEO. So we walked back to the hotel, and it was great. It was just fantastic. So it was really fun stuff. I mean, I didn't write test programs for ridiculous things. I got out of doing a test program for a karaoke chip, but I got to do stuff like the Doppler shift. That was great. I did some really amazing stuff, and it's been a really fun career. And electronics, if you can get the right job, electronics is great. If you get a bad job, well, it's going to suck, but that's always true for any job. Anyway, that's enough for now. So take a look at the book, The Reluctant Road Warrior, if you get a chance. It's kind of fun. If you're into electronics, it'll definitely be fun. That's it for now. From the river, from Fort William Bend, this is Dan Bullard. See you later.